Humans have been great explorers. So what is next stop for the human civilization to explore? The answer is Mars. Mars shares many similarities with that of Earth, which includes the day-night cycle, land mass, tilted axis, polar ice caps, and even the landscapes to some extent. Researchers have also found out presence of early rivers and valleys on the Martian surface. But, Mars also has a lot of potential problems which make them uninhabitable to human beings, such as a low atmospheric pressure, an atmosphere which contains 96% CO2 and which is only 1% of that of the Earth's atmosphere, absence of any form of liquid water, a gravity of 3.8, which is 1/3 of the Earth's gravity, no plants or trees or any form of life which provides food and other requirements. So how do we start a human settlement on Mars? And what is the role of an architect on such a project? The journey to Mars is of 8 months, and then even if a person have to return to Earth, it would take 2 years to return. Living in small steel cabins affect humans mentally and physically. No one would like to live in such a space for 2 years. The basic aim of this project is to design a self-sustainable settlement module which could be replicated for the batches of 96 people each who would be landing on the Martian surface. So where is the project located on Mars? The project is located on the Quad 51 of MC23 Aeolis Palus. Aeolis Palus is a plain between the northern wall of Gale crater and the northern foothills of Aeolis Mons, Mount Sharp, on Mars. The NASA landed the Curiosity rover on Aeolis Palus in August 2012. The Gale crater is a probable dry lake on Mars near the northwestern part of the Aeolis quadrangle. It is 154 kilometers in diameter and estimated to be about 3 to 4 billion years old. Aeolis Mons or Mount Sharp is a mountain in the center of Gale and rises 5.5 kilometers, 18,000 feet, high. Aeolis Palus is the plain between the northern wall of Gale and the northern foothills of Aeolis Mons. At present it is found out that there are a lot of minerals and sedimentary deposits. These would be a resort to resources for human settlements. The data sent by Curiosity rover is promising for human exploration. NASA has planned the next mission of Mars 2020 to study more sample. They are also sending MOXIE, which produces oxygen on Mars on a small scale, to start testing human exploration equipment on Mars. The master plan layout is planned in a linear progressive method in which the T-base biosphere acts as the central spine of the township. The headquarters is placed as the core of the township. All functions are symmetrically distributed along the vertical axis and the settlement happens linearly along the biosphere. The T-base would also carry all the services running throughout the township. First, the settlement clusters would gradually develop along the T-base close to the headquarters. Once the surplus greenhouse is placed, the tourist biomes could be built below that greenhouse area. Above the headquarters would be the landing zone and the industrial zone. The concept was trying to evolve a human settlement module that can be repeated in batches. Since it's a cluster-wise development, the growth modules need to be flexible, and hence the hexagonal form was chosen for the site, and bilateral symmetry is maintained in each and every planning module. There is a central core just like the atomic model. The functional members are planned around that central core just like in case of a model of the atom. The functional design has tried to build an environment which is workable yet sufficing to the needs of the human settlers on Mars. The whole hexagonal module follows a bilateral symmetry where the 96 people are divided into two parts of 48 people each. There are habitation clusters, greenhouses, material extraction and manufacturing units and a central community dome at the center. The central dome houses an assembly area, medical facilities, 3D material printing studios, research facilities and communication facilities to help in communication from the module to Earth. All the services essential such as water, oxygen, energy etc. are produced outside and are supplied along through the periphery of the hexagon. The movement to these buildings are through a pressurized tunnel and thus the people do not need to wear pressurized suits to move from one facility to another inside the hexagon.